Hey everyone, this is Dr. Matt C. Howard and welcome to week 11 of your Business 255 course. This week we're going to cover a very brief review of regression. We've already gone over it several times, but it has been a week since we had class, so I thought it would be a good idea just to get a brief reminder of what regression is. And then we're going to cover dummy coding. Despite its name, dummy coding is actually a little bit complicated. It's a little bit complex of a topic in regression, so make sure you pay attention to this video and make sure that once you get to the guide that you actually follow the guide before you start trying to do the homework, because this is sometimes a tough topic. Okay, so in the last few classes we've learned about regression. So what is regression used to do? As you hopefully said, it's used to determine the linear relationship between an outcome and its predictor or predictors. You may have one predictor, you may have two predictors, you might have 100 predictors. But regression is used to find the linear relationship between all those predictors and a single outcome. So regression tries to find the test statistics that best describe the relationship between the predictor and the outcome. And when there's more than one predictor, it does this for each predictor in the outcome. So as you hopefully remember, once you do a regression, you get a beta naught, which is the intercept, which is the starting value of the outcome when all the predictors are 0. So that's thought of as kind of the beginning point for the outcome. And then you get your beta 1, the beta 2, and the beta 3. And that gives you an indicator for every 1 unit increase in the predictor, how much does the outcome go up? So if predictor A goes up by 1, how much does the outcome go up? If predictor B goes up by 1, how much does the outcome go up? And if predictor C goes up by 1, how much does the outcome go up? And that answer, or that question, can be answered by beta 1, beta 2, and beta 3 respectively. That beta 1 gives you an estimate of the linear relationship between predictor A and the outcome. Beta 2 gives you an estimate of the linear relationship between predictor B and the outcome. And beta 3 gives you an estimate of the linear relationship between predictor C and the outcome. And also, as you hopefully remember, when analyzed together, regression estimates each relationship while controlling for the others. And what does that mean to control for the others? As you remember, or hopefully remember, we visually demonstrated this concept by using a Venn diagram. We showed where the variables overlapped in predicting the outcome, and regression tries to partition that variance. Regression tries to determine, well, in that area of overlap, should it be considered part of predictor A's predictive ability, part of predictor B's predictive ability, or should it be part of predictor C's predictive ability? So therefore, regression estimates each relationship while controlling for the others. It gives you the effect of outcome A above and beyond B and C. It gives you the effect of outcome B above and beyond A and C. And it gives you the effect of outcome C above and beyond A and B. So when performing a regression with multiple variables, the results determine the variance in the outcome that can be attributed to each predictor. So therefore, it's a very powerful tool, and it gives you more nuanced information than just a correlation or just a regression with one predictor if you have more than one predictor. So in other words, it tries to figure out which parts of the overlap should go to each predictor. So that's our brief review of regression. That was 3.5 minutes. So hopefully that's sufficient to cover regression. If you have forgotten it so much that this review was not sufficient, please go back and watch the prior videos. Regression will be something that's on the test, pretty extensively on the test. I believe every question on the upcoming test will involve regression. So if this review didn't spark enough light bulbs, if that's a figure of speech, then make sure you go back and watch the prior videos. But if you feel comfortable with that, let's go on and talk about dummy coding. Let's talk about dummy coding. So thus far, we've conceptualized the analyses we've learned in this class as either determining the relationship between variables, such as correlation and regression, or the differences between groups, such as t-test and ANOVA. So far we thought about things such as, well, what is the linear relationship between conscientiousness and job performance? Or things like the difference between groups, such as, does training group A perform better than training group B? And these are two different categories of analyses as we conceptualize them so far. However, you might come across instances where you think, well, what if I want to do both at the same time? What if I want to determine the differences between these groups in my data set, as well as the linear relationship between certain variables at the same time? So for instance, you could ask yourself, what's the difference between training groups on performance, and what's the relationship between conscientiousness and performance? So you could want to determine if there's a difference between training group A and B on performance, as well as, at the same time, whether conscientiousness predicts performance. And you might be asking yourself, well, there might be another instance I want to do both at the same time. Can you think of when that might be? Well, you might want to do both at the same time if you want to control for the effect of the other in the analyses. So for instance, if you work at a workplace and you know for sure conscientiousness predicts job performance, you know conscientiousness has an effect. So therefore, if you're testing the difference between two training groups, you might want to say, well, I want to go ahead and account for that variance I already know matters. I might want to go ahead and capture that variance that's explained by conscientiousness when I test the difference between group A and B. So therefore, you might would do the training groups, you might would measure performance, but you might go ahead and measure conscientiousness for every employee. So you can go ahead and capture that variance that conscientiousness explains in performance, and then at the same time test the difference between group A and group B in the two training programs. So therefore, we have very valid instances where we might want to do both, look at the difference between groups, such as the difference between training group A and training group B, as well as look at the linear relationship between variables such as the predictive ability of conscientiousness in predicting job performance. We might want to do both at the same time. And we can actually do this using regression, believe it or not. So regression, even though we've been conceptualizing it as just testing the linear relationship between two variables, regression can actually test the differences between groups. So regression can not only look at the linear relationship between two variables, but it can also look at the differences between groups. And we call that dummy-coded regression. So as you can see on this chart, this is a chart that we visited and revisited multiple times this semester. We have still the relationship between variables, we have still the difference between groups, but now we have a new category, we have a new addition, and it's both. What if we want to both look at the relationship between variables as well as look at the difference between groups at the same time? We would do dummy-coded regression. We would do a dummy-coded regression analysis. So as I said, we can test the mean differences between groups using regression, and we'll go ahead and start with the easiest example. So we're going to use regression to analyze the difference between two groups. So no other variables, we're not looking at any linear relationships at this point, we're not looking at anything with more than two groups, we're just wanting to know whether regression can test the difference between two groups. So this might be training group A versus training group B, and we measured their performance. And we're trying to determine whether employees who went through training group A have better performance than those who went through training group B. So this is the easiest example you can think of when it comes to dummy-coded regression. So to do this, our data set would have two variables. One would be our outcome, and one would be our grouping variable. So the example we're going to use, we're just going to call our outcome. You can pretend that's whatever you want, maybe test scores, maybe professor satisfaction ratings, whatever you want it to be, you can make it whatever you want. So we have an outcome in our data set, and as you can see, we have a grouping variable. And to start, our grouping variable is just Dr. Howard and Dr. Smith. So whoever recorded this data set just wrote down whatever class the student was currently in, and then they measured some type of outcome. So we have 5 students in Dr. Howard's class, we have 5 students in Dr. Smith's class, and they were measured for some type of outcome. However, to do dummy-coded regression, our grouping variable needs to be coded as 0 and 1. And if we use different numbers, we're going to get different results. And our results might be inaccurate if we get different numbers. There are other ways you could code this that are legitimate. There's also something called effects coding, and there's many other types of coding. But dummy coding explicitly refers to when you code it as 0 and 1. And that's what I'm going to want you to do in this class. So whenever in this class, and as you move forward in your academic career or professional career, whenever you hear the word dummy coding, that usually always refers to coding a categorical variable with 0s and 1s. And that's what I want you to do. So we're going to take our data from before and we're going to code it as 0 and 1. So in this example, we took all of Dr. Howard's students and coded it as 0. and then we took all of Dr. Smith, I believe, students, and coded it as 1. So we go ahead and do dummy coding and code it as 0 and 1. When it comes to statistical significance, it doesn't matter in this example which one you code as 0 and 1. However, it will affect the direction of your results, but for the purposes of this class, don't really worry about that much. We'll cover how to determine how to interpret your results. So anyways, we're going to go through an example in Excel in a few minutes, and also you'll have a guide to complete this week. But once you make your dummy variable, you just run a regression. You just run a regression with your outcome variable as your outcome, and your dummy variable as your predictor. Your variable is 0s and 1s as your predictor. So you run your regression, and it might look like this. It might say, well, your beta, as you can see there, is 0.365. Your standardized beta might be 0.427. And then you have a t statistic. Your t is 3.889, and it has 2 asterisks. What does that mean if you have 2 asterisks? As you hopefully said, that means your results are statistically significant. So you would go ahead and put your dummy variable in your regression. You would run your regression with your outcome as the outcome, and then you would get results like this, and maybe your result would be statistically significant. So that would mean there's a statistically significant difference between the 2 groups you are comparing, so Dr. Howard and Dr. Smith. So in this example, we would say there is a significant difference between Dr. Howard and Dr. Smith's courses in regards to the outcome. So we know there's some type of difference. So once you know that there's a difference, how do you figure out which group was actually higher, which one was significantly higher? Probably the easiest way, if you're just looking at 2 variables, is to go ahead and calculate the group means. So just go ahead and calculate the group means, and as you can see in this example, group 0 had a mean of 7.1, and group 1 had a mean of 7.465. So try to think for a second about exactly what that would mean in these results. As you hopefully thought to yourself, this would mean that there is a significant difference between Dr. Howard and Dr. Smith's course, and because we coded Dr. Howard as 0 and Dr. Smith as 1, that would mean Dr. Smith's students had significantly higher values on the outcome than Dr. Howard's students, whether that would be professor satisfaction, maybe professor dissatisfaction, or something else altogether. Whatever it is, we know that there is a significant difference in the groups, and because we coded Dr. Howard as 0 and Dr. Smith as 1, and the means were 7.1 and 7.465, we therefore know that Dr. Smith had a significantly higher value than Dr. Howard. So you might be asking yourself, well, how does all this work? Why does it make sense to run a regression when you have these different grouping variables? And here's a visual representation of what's going on. And this is a different example. This is an exaggerated example. But when you're running a dummy-coded regression, it's just the same as any other regression. You can think of it as a scatter plot. And what's going on is you can see on the x-axis, that's your predictor. The group code down there is your dummy variable. And as you can see, the only values were 0 and 1. So one way to think of it as what regression does is it makes a scatter plot just like we were doing before. And as you can see in this example, those that were coded as 0 had values of 1, 2, or 3. They were very low, they're down there on the axis, very low values. And then those that happened to be coded as 1 had very high values. They were 11, 12, and 13. So what regression does, one way to think of it, is it makes a scatter plot like this, and as you remember, regression tries to make the line of best fit. It tries to draw the line that best fits this data. And try to think for a second, what would the line look like that best fits this data? Hopefully you said it would be very steep, and it would be positive. This is the line that best fits this data. So what regression does is it tries to draw a line that connects group 1 to group 2, or sorry, group 0 to group 1, and then it gives you results based on that. So if the groups are very far apart in their values, that line is going to be steep and it's going to be significant. However, think of another example where if those 2 groups were closer together, let's say both the groups had values of 5, 6, and 7 and 5, 6, and 7, then the line that would connect the 2 groups of 5, 6, and 7 and 5, 6, and 7 would be completely flat. And what does it mean when we have a flat regression line? Hopefully you said that means our results are not statistically significant. hopefully that means that you said our results are not statistically significant if our regression line is flat and if the two groups have very similar values. So that's in a nutshell how dummy-coded regression works, is it takes our values, we dummy code it, we make those groups with zeros and ones, and then visually, if you wanted to visually represent it, you make a scatter plot, and then you're drawing the line of best fit that best describes that scatter plot. So there we go, that's our visual representation of dummy coding. That's a brief explanation of it. If we wanted to do slightly more advanced dummy coding, like we said in the beginning of this lecture, if you want to test the difference between groups as well as the linear relationship between variables, you would just go ahead and add those other variables to your regression analysis. So let's look at the same data set. We still have that dummy variable we coded as 0 and 1. We still have our outcome, but now we have conscientiousness as a predictor. Now we have conscientiousness in our data set. So we still have the dummy variable, we still have the outcome, and now we have conscientiousness. And all we do that's different is we will run a regression with our outcome as the outcome, and with dummy variable and conscientiousness as the predictors. So once again, it's pretty much the same as all regressions we always do. We just run a regression with our outcome as the outcome, and the dummy variable and conscientiousness as predictors. So if we were to run that regression, this might be what our results would look like. As you can see, we have our betas, and we have our t-values, and we have asterisks next to those t-values. So as we see, there is an asterisk next to the dummy variable t-value, and an asterisk next to the conscientiousness t-value. So take a second, think about what this would mean. So hopefully you said to yourself, this would mean that there is still a significant difference between the groups because our dummy variable is still significant. Our dummy variable still has a significant effect, so therefore there is a difference between the groups, and we would probably need to go ahead and calculate the group means to determine the nature of those differences. But this also means that conscientiousness has an effect even when accounting for those group differences. So the effect of conscientiousness is still significant even when accounting for group differences. And conversely, the group differences were significant even when accounting for conscientiousness. So in this example, both there was a significant group difference and a significant linear effect of conscientiousness on the outcome when accounting for each other. So there you go. There's dummy coding in a nutshell. That's a brief overview of the concept. So now if you have any questions, pause the video, shoot me an email. I'm happy to answer anything. But otherwise, let's go ahead and briefly look into how to do dummy coding in Excel. And this is pretty much the example I just gave before. And this is going to be similar to the guide that I provide. The guide's going to be slightly more complicated than this, so it might be a good idea to watch this video first and then go ahead and do the guide. But this will be slightly different. This is a slightly easier version than the guide. So as you can see in this example, we have class, Dr. Smith, Dr. Howard. We have students' GPA, and then we have their test grades on a test. So therefore, in this example, we're wanting to see if what class the students are in predicts test grades, if GPA predicts test grades, and whether the two of those predict test grades when accounting for the other. So therefore, right off the bat, you should tell yourself, we should do dummy-coded regression, because we're looking at the differences between groups with Dr. Smith versus Dr. Howard, and we're looking at a linear effect of a predictor on the outcome with GPA predicting test grade. So if you're doing this in Excel, it's pretty simple. The very first thing you should do is take all those classes, Dr. Smith and Dr. Howard, and you should dummy code them. There's many different ways you could go about this, but when your data set's pretty small, you could just go ahead and do it by hand. So in this example, I just went through by hand, and I changed all of Dr. Smith's students to zeros, and all of Dr. Howard's students to ones. So you can go ahead and by hand, change the values of Dr. Smith to 0, and Dr. Howard by 1 whenever you're doing dummy coding. So once you make the dummy codes, once you have the dummy codes made in your data set, you want to go to data analysis. You want to click on regression like we always do when we do a regression, and then you want to click on OK. So we went from data analysis, we clicked on regression, and then we clicked on OK. So from here, we want to go ahead and input our Y range. So we click on that button that's highlighted like we always do to input our outcome or our Y range. And we want to go ahead and highlight test grade. We want to go ahead and highlight all of those data values. And in this example, I went ahead and highlighted the label. So you want to go ahead and highlight test grade, including the label, and then push that other highlighted button. Once you do that, you need to input your X range. So this is our predictor range. So you need to input your X range or your predictors by clicking the highlighted button. And then you want to go ahead and highlight both the class variable and the GPA variable. So go ahead and highlight both the class variable and the GPA variable, including the labels, and then push that other button that's highlighted. Then push the OK button. And once you do that, go ahead and click on labels, because we indeed highlighted the labels, and then push OK. So make sure you check that labels box and then push OK. So once you do that, you should get results that look like, well, any other regression results that you ran. So first we can look at the effects of class. So it gives us our unstandardized beta coefficient, it gives us our t-statistic, and it gives us our p-value. So based on these results, what can you say about the differences between Dr. Smith's students and Dr. Howard's students? So based on this, what can you say about the difference between Dr. Smith and Dr. Howard? Hopefully you were able to quickly identify that because that p-value is greater than 0.05, because that p-value is pretty high, you know that result is not statistically significant. You know that result is not statistically significant. So therefore, because that result was not statistically significant, there would not be a significant difference between Dr. Smith and Dr. Howard's students. We'll say there is not a statistically significant difference between Dr. Smith and Dr. Howard's students. So let's look at this next result. So this next result is GPA. We see our unstandardized beta coefficient, we see our t-statistic, and we see our p-value. So based on this result, what can you tell yourself, or what do you know? You know that because your p-value is less than 0.05, there is a significant relationship between GPA and test scores. So because your p-value is less than 0.05, you know that there's a significant relationship between GPA and test scores. So even though it didn't matter what class you're in, it does matter what your GPA is. So therefore, when accounting for class, GPA still has a significant effect. So we would say the GPA does have a linear relationship, a significant one, with test scores. Okay, so that's all for the basics of dummy-coded regression with two groups when you're looking at a categorical variable. So we just now went over when you have a categorical variable with only two groups, this is what dummy-coded regression looks like. But you might have been asking, well, what if my grouping variable has more than two groups? What if I'm looking at something with 3 groups, 4 groups, 5 groups? And we can go ahead and cover that. The process is very similar. It's very, very similar. So let's go ahead and discuss it. So if you have a grouping variable with more than 2 groups, you make a dummy variable for the number of groups minus 1. You go ahead and you make a dummy variable for the number of groups minus 1. So if you have a grouping variable that has 3 groups, you make 2 dummy variables. If you have a grouping variable with 4 groups, you make 3 dummy variables. If you have a grouping variable with 5 groups, you make 4 dummy variables, etc., etc. So you make a dummy variable for the number of groups minus 1. And here's an important distinction. As you remember, we had to code things as 0 and 1 before. You're still doing that with the multiple dummy variables when you have multiple groups. However, when you have more than 2 groups, there's going to be one group that's never 1 in your dummy variables. There's going to be a group that is always 0 in your dummy variables. And you have to choose which one that is. So once again, when you're doing dummy-coded regression, you have to make dummy variables. You still have to use 0s and 1s. There's going to be one of those groups that's always a 0. It's never a 1. And you choose which group that would be. Whichever one you choose to be always 0, that is the comparison group. So the group that is never 1 is the comparison group. So your results are in relation to that group. So the result of your first dummy variable will be the difference between your comparison group and alternative A. Dummy variable 2 would be the difference between your comparison group again and alternative B, and etc., etc., etc. So whichever group is always 0, whichever group is never 1, that's going to be your comparison group. and all your results will be relative to that comparison group. That might be a little bit confusing at first look, so we'll talk about an example. So here might be what our dummy code or what our data set might look like if we have more than one group, or sorry, more than two groups in our categorical variable. So in this example, we have a categorical variable, which is professor, and we have an outcome, just like before. But the one small difference is that now we have Dr. Howard, we have Dr. Smith, and now we also have Dr. Chow. So we have Dr. Howard, Dr. Smith, and Dr. Chow. We have more than two groups in our grouping variable, but we can still use dummy-coded regression to look at the differences between the groups. So from looking at this data set, how many dummy variables do I need to make? Hopefully you said 2, and that would be correct. We make two dummy variables. So in our data set, we have Dr. Howard, Dr. Smith, and Dr. Chow. We would make two dummy variables. And we still code as 0 and 1. So as I said before, one of these groups you have to designate to always be 0 across all of these dummy variables. So one of these groups has to always be 0 across all these dummy variables. So which one did you want that to be? In this example, I chose Dr. Howard. So with dummy variable 1 and dummy variable 2, Dr. Howard was always 0. So I went ahead and put zeros in for Dr. Howard across all of those dummy variables. And then for the other groups, each dummy variable will have one group as 1 and all the others as 0. So each dummy variable will have one group as 1 and all the others as 0. So because Dr. Howard was already designated to be 0 across all of them, we knew Dr. Howard was 0 in both dummy variables. Then for dummy variable 1, we made Dr. Smith's students 1 and all the other students as 0, which would be Dr. Chow's students. For dummy variable 2, we made Dr. Smith's students 0 and Dr. Chow's students 1s. The important thing is for each dummy variable, only one group can be 1 and all the others have to be 0. So for each dummy variable, only one group can be 1s and everything else has to be 0. So as you can see in this example, in dummy variable 1, only Dr. Smith's students was 1. In dummy variable 2, only Dr. Chow's students were 1 and everything else was 0. And we chose ahead of time Dr. Howard would be 0 across all the groups. So that makes Dr. Howard the comparison group for our dummy-coded regression results. Okay, so let's go ahead and continue. When you're doing a dummy-coded regression with more than two groups in your categorical variable, you then add both dummy variables to your regression. Do not only run a regression with one of the dummy variables. If you have more than two groups, you have to run your dummy-coded regression with all the dummy variables. Don't do it with just one. You'll get it wrong. You'll miss the points on the test. You'll miss the points on the homework. Make sure you include all your dummy variables in the regression. So this might be what the results look like. So as you can see, we included both dummy variables. We included dummy variable 1 and dummy variable 2. And as you can see in this results, we have our betas, we have our t-statistics, and we have the asterisks that represent our p-values. So based on this, take a second. Well, I provided the text there already that tells you the answer, but take a second and see if you can figure out what are these results telling you. Try to think for a second, what are these results telling you? Okay, so in this one, first off, as you can tell right off the bat, dummy variable 1 is significant, whereas dummy variable 2 is not significant. Dummy variable 1 had the asterisk next to the t-statistic, so therefore it's significant, whereas dummy variable 2 did not have any asterisks, so therefore it is not significant. So based on this, because dummy variable 1 represented the comparison between Dr. Howard and Dr. Smith, because we chose Dr. Howard to be the comparison and Dr. Smith was the 1s in dummy variable 1, we would say that there is a significant difference between Dr. Howard and Dr. Smith in these results. So we'd say there is a significant difference between Dr. Howard and Dr. Smith in these results. So, like we did before, if we wanted to see the nature of that difference, we would go ahead and calculate the means for those two groups. And we would try to see which one had a significantly higher mean, which one had a significantly lower mean, but based on this, we know that there is some type of difference, a significant difference, between Dr. Howard and Dr. Smith's classes. And then the next part, what I have there, it actually begins with a typo. That should say because dummy variable 2, so that second part on your text there should say because dummy variable 2 represented the comparison between Dr. Howard and Dr. Chow, we would say there's not a significant difference between Dr. Howard and Dr. Chow. So based on these groups, dummy variable 2, we chose Dr. Howard to be the comparison, and for dummy variable 2, Dr. Chow was the ones. So because we chose Dr. Chow to be the ones for that dummy variable, that's the comparison. Dummy variable 2 is the comparison between Dr. Chow's students and Dr. Howard's students. And because that dummy variable is not significant, we would say there is not a significant difference between Dr. Howard and Dr. Chow based on these observed results. So once again, take note of that typo. The first part is correct. The second part should begin with because dummy variable 2. It should not say because dummy variable 1. So sorry about that typo. Hopefully you have the audio on. Hopefully you're not just skipping around in this video. But if you have any questions, let me know. Okay, so from this, just like before, we can add other variables to the regression, and we can analyze their impact in addition to the grouping variable, just like we did before. So let's take the same data set, once again with Dr. Howard, Dr. Smith, and Dr. Chow. Let's once again have the same dummy variables with Dr. Howard as the comparison, and Dr. Smith as the ones in dummy variable 1, and Dr. Chow as the ones in dummy variable 2. So dummy variable 1 is the comparison between Dr. Howard and Dr. Smith. Dummy variable 2 is the comparison between Dr. Howard and Dr. Chow. But now we have conscientiousness. Now we want to look at the differences between the groups in addition to the relationship between conscientiousness and the outcome. We want to do both. So we would do the same thing we did before, run a regression with the dummy variables, run the regression with conscientiousness, and see what's significant. And as you can see, dummy variable 1 is once again significant. So we would still say there's a significant difference between Dr. Howard and Dr. Smith based on these results. Dummy variable 2 is still not significant. So we would say there is no difference between Dr. Howard and Dr. Chow based on these results. And then we would say that there is a significant effect of conscientiousness, and therefore there is a significant linear relationship between conscientiousness and our outcome, whatever that might be in this example. So together we would say once again, based on these results, there's a significant difference between Dr. Howard and Dr. Smith in this data set. There is not a significant difference between Dr. Howard and Dr. Chow in this data set, and there is a significant relationship between conscientiousness and our outcome in this data set. And the guide I send you this week, and it's also in the comments below, will show you exactly how to do this analysis in Excel. This is the analysis that we'll walk through together in the guide. So if it's a little bit hazy to you right now, if it's a little bit confusing, feel free to shoot me an email, but you're going to see a step-by-step process of how to do this analysis with an explanation in the guide I provide that you can do together in Excel. So if you have any questions, shoot me an email. Otherwise, that's all for this week's lecture. It's shorter than I thought it would be, but when I teach this in person, I have tons of questions from the students, so I expect to get emails from you this week. I expect to have some students be confused, and that's okay. When I teach this in person, this usually takes at least an hour and 15 minutes to get through this lecture, but because it's online, because I don't have any questions, it's much shorter. So please shoot me an email with your questions. Otherwise, do the guide, don't forget the homework, and I'll talk to you next week.